Ever rubbed the plastic comb on your sweater and seen tiny paper bits leap up and cling to it? It's fun, but did you know that simple act reveals something far deeper about the world? That invisible pull hinted at a force no one could see, until scientists began to ask, what is matter really made of? Welcome to the fascinating journey inside the atom, a world where matter isn't solid but a delicate dance of invisible particles. In the late 1800s, scientists like J.J. Thomson began passing electricity through gas-filled glass tubes and stumbled upon a discovery that changed physics forever. They noticed glowing rays streaming from the negative end, the cathode, to the positive one, the anode. These mysterious rays could spin tiny wheels, cast shadows, and make things glow, but what were they? Thomson proved these weren't just rays, they were tiny, negatively charged particles. He called them electrons, the first subatomic particle ever discovered. Regardless of the gas used or the electrodes applied, these electrons behaved the same, proving they exist in all atoms. Discovering the electron was only step one. Next came measuring it. J.J. Thomson calculated how much charge an electron carries for every kilogram of its mass, a value known as the charge-to-mass ratio, or E by mE. And the value? 1.758820 into 10 to the power 11 coulombs per kilogram. That's how much negative charge 1 kilogram of electrons would carry, if you could ever gather that many. Okay, we had the charge-to-mass ratio. But what's the charge of a single electron? Enter Robert Millikan and his ingenious oil drop experiment. He sprayed fine oil droplets into a chamber and used X-rays to make them pick up extra electrons. Then, using electric plates, he suspended those charged droplets in midair, perfectly balanced between gravity pulling them down and electricity pushing them up. From this delicate balance, Millikan found the charge on a single electron is minus 1.602 into 10 to the power minus 19 coulombs. Yes, that tiny. Electrons were just the beginning. What about the rest of the atom? When scientists studied positive rays, called canal rays, they discovered protons, positively charged particles with about 2,000 times more mass than electrons. Later, in 1932, James Chadwick completed the puzzle. By bombarding beryllium with alpha particles, he discovered the neutron, a heavy, neutral particle. No charge, just mass. Together, these three form the atom's core structure: electrons, light and negative protons, heavy and positive neutrons, heavy and neutral. Fun fact: one proton weighs about 1.672 into 10 to the power minus 27 kilograms, while an electron is a featherweight at 9.1 into 10 to the power minus 31 kilograms. Still think electrons, protons, and neutrons are just textbook trivia? Think again. Electrons power your smartphone, your laptop, your life. Protons decide which element we are talking about. One proton? That's hydrogen. 6. That's carbon. Neutrons hold atomic nuclei together, and when released, they drive nuclear power and nuclear bombs. Subatomic particles aren't invisible fluff, they shape our world from electricity to energy, chemistry to civilization. Let's wrap up with a quick numerical and final recap. First, here's the question: how many electrons weigh exactly 1 gram? We know that the mass of one electron is 9.1 into 10 to the power minus 31 kilograms. And 1 gram is 1 into 10 to the power minus 3 kilograms. So, to find the number of electrons, we divide 1 into 10 to the power minus 3 by 9.1 into 10 to the power minus 31. That gives us approximately 1.1 into 10 to the power 27 electrons. That's an unimaginably huge number. Next, remember the charge-to-mass ratio of an electron, also called E by ME, is 1.758820 into 10 to the power 11 coulombs per kilogram. The charge on a single electron, discovered by Millikan, is minus 1.602 into 10 to the power minus 19 coulombs. And finally, atoms, the building blocks of matter, are composed of just three fundamental subatomic particles: electrons, protons, and neutrons. Understanding these tiny particles helps us understand the universe itself.